we're now getting into scientific notation with negative exponents. Now, negative exponents imply that we have small numbers. And when I say small numbers means less than 1. So when you look at this first one, 0.7, 0.7 is less than 1. So scientific notation, remember, we want the decimal to be after the number. So this would be 7 times 10. I moved the decimal one place. Small number means negative exponent. In the second one, I had to move the decimal 2 places, so we would have a -2. And in the third one, we moved it 3 places, so we would have a -3. So notice, small number, if your number is less than 1 in standard form, you are going to have a negative exponent when you go scientific notation. So when we go scientific notation here, remember, your rules of scientific notation stay. We want the first number to be between 1 and 10. So 4.93 times 10, this is less than 1, so it's negative, and I had to move it 1, 2, 3 places to get there. Here in the second one, I go 2 places to get my 5 times 10, small number, so it's negative, and I moved it 2 places. Wow, look at this one. When you count all of these zeros, there are 19 zeros, or at least there should be. So that means to get to the 8.411, I'm going to go 19, 20. So 10 to the -20th, because there's 19 zeros, and I got to go one more place to get it past the 8. Now, 8 thousandths. There's 2 ways you can think of this one. If you first want to put it in standard form, thousandth means 3 decimal places, which kind of like thousand, which is 3 the other way. Thousandths, THS at the end, means we're less than 1. So we would go 1, 2, 3 and have 8 to the -3rd. Or you can think of this kind of how we talked about 1,000 is to the 3rd, million is 6, billion is 9. Same concept. But when you have the THS, that means smaller than 1. And there is our -3. So you can kind of think of that 2 different ways. 96 million. As I just mentioned, million is 6. So this is 96 times 10 to the 6th. Well, this, we need to move it over, but 96 is a big number. So our exponent's going to go up by 1, and 9.6 times 10 to the 7th. That's kind of a review of what we've done in the past. Here, number 6, I'm going to move it 1, 2, 3, 4, 5, 6. 4.1 times 10 to the -6, because again, this number starts out as less than 1. In number 7, this number is bigger than 10, so I know my exponent is going to be positive because it's big. 369 times 10 to the 9th. All right, 6 tenths. Well, that's this number, 6 tenths. It's 1 decimal place, so I'm going to go 6 times 10 to the -1. All right, now we're going to go to standard notation. Now, the -6 tells us we're going to move our decimal. We're going to make our number get smaller by 6 decimal places. So right now, I have 7 point. I'm going to go 6 places. 1, 2, 3, 4, 5, 6. And here's my new decimal point. So I've got a decimal point, 1, 2, 3, 4, 5 zeros, then my number. So when you think about this, you're moving it 6 places, and this number is going to be one of the spots. So you're always going to have zeros. The number of zeros is going to be 1 less than this number. So this is a 6, so I'll have 5 zeros. Here I'm going to go -2, so I'm going to take this decimal and go 1, 2. So I have 1 0 and then my non-zero numbers. -1 just moves it 1 place, and I have 0.93. Just remember to keep your decimal places. You need them when they're in the front. In this one, we have a positive. Remember, positive makes my number get bigger. So 15,921. So always remember, positive exponents make my numbers bigger. Negative exponents make my numbers smaller. So negative exponent, 1, 2, 3. I'm going to start with 2 zeros, then 515. Here again, positive. I don't see my decimal, so it's at the end. 2 places. This is just 100. -9. I'm going to go 9 places this way. That means, how many zeros do I need? Well, here's 1 place. The rest are going to be zeros. So I need 1, 2, 3, 4, 5, 6, 7, 8 zeros. That 9 here is my 9th number, and then I have my other non-zero numbers. Similar here, I have -5. So I'm going to go 1, 2, 3, 4, 5. I need 4 zeros and then all of my non-zero numbers. All right, let's do some mathematics here with scientific notation. I'm going to go ahead, this says divided, so I'm going to go ahead and write it as a division problem because that's kind of how I roll. Now when I divide, I start with my numbers. 8 divided by 1.6 is 5, times 10 to the, now I subtract. 2 minus 6 is negative 4. So this is scientific notation. I'm going to move it 4 places to the left, and it starts here. So I'm going to have 1, 2, 3, 4, right? Because my decimal point started here, and when I moved it 1, 2, 3, 4, it ends up in the front. So there's my answer in scientific notation and standard notation. Now let's go ahead and multiply. So when I multiply in these two, I multiply my beginning numbers, and I get 7.918. That's between 1 and 10, so life is good. And I'm going to add negative 4 plus 7 is 3. So here is scientific notation. To go standard, I have a positive number. I'm going to go 3 places to the right. 1, 2, 3. And 7,918 is my answer. Number 3, again, we're going to divide. So I start with my numbers. 5.88 divided by 3.2, and I get 1.8375. That's between 1 and 10, so we're good. Now I'm going to subtract my exponents. Darn it. 2 minus negative 5. 2 negatives is a positive, so this makes us times net 10 to the 7th in scientific notation. If I move my decimal 7 places to the right because I'm getting bigger, there's 4, 5, 6, 7. And 18,375,000 is my standard notation. Last one, again, we're going to multiply. So 4.06 times 2.17 is 8.8102. Between 1 and 10, so I'm good. Times 10 to the negative 7 plus 4 is negative 3. Here's scientific notation. Negative 3 means I'm going to go left 3 places. So 1, 2, that 8 is the third one. And I have a number smaller than 1 in standard notation. And I believe that's the end of that video.